In this video, we're going to be taking a look at expressing probability as a fraction. Now, today's goal, and I want you to write this down in your notes, you're going to be using fractions to represent the probabilities of events and use probability to decide if a game is fair or unfair. So that is the goal for today. Now let's take a look at what probability of an event even is, and I want you to write these things down in your notes. So the probability of an event is a number that describes the chance that an event will occur. Okay. Now, in order to write this as a fraction, what you want to do is have the number of favorable outcomes as the numerator or the top number on the fraction, and then also the number of possible outcomes as the denominator or the bottom part of your fraction. Okay, for example, if there were 3 students and I would ask you what is the probability that one student would be picked, the probability would be 1 over 3. Okay, because 1 is the number of favorable outcomes we're looking for, 3 possible different students I could choose. Now, the probability of an event can range from 0 for an event that is impossible to 1 for an event that is certain. Okay, so we could see if you even look at this number line here. Okay, less likely 0, equally likely is when really your fraction can be reduced all the way down to 1/2, and then more likely would be 1, okay, or certain. Okay, so the further you move to the right of this number line, the greater possibility or the greater probability the event will happen. Now we're going to take a look at some of these problems, give you some examples here. Okay, so we have an example A. You can just follow along. You don't need to write anything down or do this problem with me or anything like that. It says Beatrice wrote each letter on her name on a slip of paper, and she puts the slips in a bag. If she draws one slip of paper from the bag, what is the probability of drawing a vowel? Okay, so we have our different letters to the right. Now we could see there are 8 possible letters. Okay, 1, 2, 3, 4, 5, 6, 7, 8 possible letters. Okay, now we can see that there are only 4 vowels. Okay, we have A, E, E, and I. So 4 vowels. Okay, so the probability of drawing a vowel would be 4 because that is the desired outcome out of 8. That's the possible letters that are in there. Okay, so the probability of drawing a vowel is 4 over 8 or 1 over 2. Okay, so the probability as a vowel, if you want to reduce this to simplest terms, which we really haven't gotten to yet, however, you can divide both numerator and denominator by a number that goes into both of them. In this case, 4 goes into the numerator, 4 goes into the denominator. So the probability of drawing a vowel would be 1 out of 2 chances here. Let's take a look at another problem. Okay, we're trying to figure out is 2 penny toss a fair game. Okay, so how to play. First of all, we got to look at the rules. Toss 2 pennies at the same time. If both pennies land heads up, player A wins. If one penny lands heads down and the other tails up, player B wins. If both pennies land tails up, no one wins. Okay, so first of all, we need to figure out some of the possible outcomes. So we can make a tree diagram that we have right here. Okay, so the possible outcomes, there are actually 4. Heads, 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 tails, tails, heads, tails, tails. Okay, so the probability of both landing on heads, you can see heads, heads, 1 out of 4. So 1 represents the desired outcome, 4 the total amount of outcomes. 1 head, 1 tail. Okay, you can see 1 head, 1 tail, 1 tail, 1 head. So 2 out of 4. Or that could be 1 out of 2 chances. Okay, so both tails we can see 1 out of 4 chances as well. Okay, just like both being the heads. Now it says player A is less likely to win than player B. Okay, we can take a look at that based upon the probability. So whenever there's not an equally likely chance, whenever you're playing a game, it is always going to be unfair. Whenever it's a unless it's an equally likely chance for a game. Okay, let's take a look at another problem here. Now it says you spin the spinner once, find P, and that P represents probability of it landing on red. Now just remember, probability in an event is the number of favorable outcomes as the numerator over the number of possible outcomes as the denominator in your fraction. Okay, so what we can see, we want to find the probability of red, so we can see that there are 2 red colors. Okay, so the numerator would be 2, and then as far as the denominator goes, we need to just figure out how many total spaces there are, including the red as well. Okay, get a bright color here that will show up on everything. There we go. So we could see there are 1, 2, 3, 4, 5, 6 possible outcomes. So 2 out of 6 chances could be red. Now if we take a look at this 2 out of 6, we need to see, is there a number that can divide evenly into 2 and 6, and 2 can go into both 2 and 6. Okay, so 1 out of 3 chances that probability could be reduced down to. So 1 out of 3 chances would be for me to spin on the red. Okay, I want you to do this problem with me in your notes. Okay, it's saying that suppose you toss a quarter and a dime. Now we know both quarter and a dime have a heads and a tails. So it says make a tree diagram to show the possible outcomes. So if we're taking a look at if one lands on heads and tails, okay, so we can see our heads and our tails. So you can have a heads on one, heads on the other, heads on one, tails on the other. Or you can have a tails on one, heads on the other, tails on one, tails on the other. Okay, so we can see that there are 4 possible outcomes. Okay, we can see heads, heads, could be the first one, heads, tails, could be the second outcome, tails, heads, and then finally tails, tails. So 4 possible different outcomes. Okay, now we'll be able to take this information, and now what we will do is we're going to answer some of the questions that follow along here for this problem. So it says find P, or probability of 2 heads. So we can see that 2 heads in our list here only occurs 1 time. Okay, so that's going to be the numerator, so to speak, of my fraction out of 4 possible chances. So I could see 1 out of 4 chances would be the probability to land on 2 heads. Okay, find the probability for 2 tails. Okay, you can see once again that there are only there's only 1 tails, 1 event that has 2 tails occurring, so the probability would be 1 out of 4 chances because there's 4 total possible outcomes. Find the probability of 1 tail, 1 head. So what we have here, 1 tail, there's 1 head, 1 tail, 1 tail, 1 head. Okay, so for this, 2 out of 4 chances I'm seeing here would give me my probability of 1 tail, 1 head, or I could write this as 1 out of 2 chances because I can reduce my fraction down. Okay, now number 5, find probability of dime heads, quarter tails. Okay, so this could be a little bit trickier here. Okay, the dime heads and quarters tails. So we can see with that it would just still be 1 out of 4 chances because the dime could land on the head. Okay, and then the quarter tails. So only 1 out of 4. Okay, even though there's tails, heads, heads, tails, and so on, this would represent the dime landing on the heads, the quarter landing on the tails. So the probability for number 5, going to get a lot of information on here. Probability for number 5 would be 1 out of 4 chances. Okay, so let's take a look at number 6. Which of the events above is most likely to occur? Which events are least like, or which events are equally likely to occur? So I can see that one tail, one head is the event that is most likely to occur. Let me get the right pen here. Okay, one tail, one head, or one head, one tail be most likely to occur, because that's 2 out of 4 or 1 out of 2 chances for that to occur. Now, equally likely to occur, we could say that head, head, tail, tail, or tail, head, or head, tail on either coin. Okay, so we could say, once again, the probability if that's equally likely to occur, 2 heads, okay, 2 tails, okay, dime heads, quarter tails. Okay, so we could see that they are all of those are equally likely to occur. Now I want you to complete this problem in your notes all by yourself, and when you're finished you can press play and I'll have the answers for you. So pause the video now. Okay, here are the answers to these questions. Probability that an object does not use electricity if you were to spin the spinner. We have 2 out of 6 or 1 out of 3 chances. Probability that the object uses electricity, 4 out of 6 or 2 out of 3 chances. And finally, probability of object used for writing, we can see 1 out of 6 chances. Okay, so this is how you express probability as a fraction. If you have any questions about this concept, please come and see me.